In this video 3.8, we will be working with unions and intersections of sets. By the end of the video on work time in class, you should be able to say, I can find the unions and intersection of sets. For our vocabulary, a union is the set that contains all elements of two or more sets. So it's everything. It's all of the elements. So if I have a universal set, and I have A and B, it is everything in A, everything that is in both A and B, and everything in B. It's everything of two or more sets. Whereas an intersection is the set of elements that are common to every set. So if this is my universal, and here's set A, and here is set B, it's what they have in common. So it's this right here is the intersection. Disjoint sets means they have no elements in common. So in my universal, they wouldn't be overlapping. Set A and set B have nothing in common. Suppose that in a box there's a brush, a marker, and a pencil. In another box there's a calculator, a marker, a ribbon, and a brush. What items are in either box? So we're looking for the union. If it's saying in either box, we're looking for the union. And so the union would be everything. We would have brush, marker, pencil, calculator, and ribbon. In number 2, we have set X, Y, and Z, all of the real numbers X, such that X is a whole number less than 15, so that's our X set. In our Y set, it would be all real numbers Y such that Y is an odd integer. And for set Z, all real numbers Z such that Z is a multiple of 4. First, we're going to look at what is the intersection of X and Z. That is what this symbol means right here. This basically upside down U is the intersection. And so we're going to list this in roster form. We write a brace. So what is in both X and Z? So if X are whole numbers less than 15 and Z are multiples of 4, we would have 4, 8, and 12. That would fit both of those sets. It's less than 15 and they're multiples of 4. Part B here, we're going to look at the intersection of Y and Z. Y has to be an odd integer and Z is a multiple of 4. And if you think, multiples of 4 are all even, and since set Y is odd integers, what do they have in common? Nothing. So we have an empty set or a null set. We can write either one of these. This is an empty set. 3 friends are learning new languages. We're going to draw a Venn diagram to represent the union and the intersection of these sets. Which language do all 3 friends have in common? We have Matt, Rob, and Jane. So what I'm going to do is I'm going to have Matt. He's going to be this blue circle. And then Rob is going to be my green circle. And then Jane is going to be my red circle. Okay. Matt, he speaks Spanish, German, and Italian. Rob, he speaks Spanish and German. And Jane, she speaks Russian, Chinese, and Spanish. So I'm going to start with noticing that they all do have Spanish. And so I'm going to put an S here in the middle for Spanish. Matt and Rob both speak German. So that's going to go just between the intersection of Matt and Rob. It looks like Matt is the only one that speaks Italian. Jane looks like she's the only one that speaks Russian and Chinese. And so that covers all of them. And so which language do all of them have in common? You can see that is in the center, the intersection of all three, which is Spanish. So a Venn diagram helps us visualize what things have in common or what they don't have in common. Of 125 students in the 5th grade, some have music on Tuesday and some have art on Tuesday and some have both classes on Tuesday. 68 have music on Tuesday and 33 have both classes on Tuesday. How many students have art on Tuesday? So what we want to do in our Venn diagram is we want to have one of our circles, one of our sets represent music, and then the other set is going to represent art. So the green is going to be music, and the blue here is going to represent art. Now it tells us we want to know how many students have art. We want to know the blue circle. What is going to be in the blue circle? So this is what we're looking for. What is in the blue circle? Well, they tell us that 68 have music on Tuesday and 33 have both. So we have this number 68 and they have music and 33 have both. So if 33 have both, we know that that number is going in the middle here. So we have part of what's in our blue circle, which is what we're getting to. Now the other thing we know is 68 have music. So if we look at our green circle, we have 33 in the green so far, but we need a total of 68. So if we do 68 and subtract 33, we're left with 25. So that means 25 only have music, 33 have both, music and art. So now we look inside our green circle, we have a total of 68. Now one other thing we know is there's a total of 125 students. Well, if there's a total of 125 students, we right now have 68 total in our green circle. The whole total altogether is 125. So if we take away the 68, 125 minus the 68, then we borrow here. So we have 7. So that means 57 have art, or should be in the blue circle. So 57 should be the total in the blue. We need to figure out this number right here. And so that means we would do 57. Oh, no, sorry about that. This number right here is 57. Right here. Because now we see that 25 plus 33 plus 57 gives you 125. But now the question is, how many are in the blue circle? And that would be 57 who just have art plus the 33 who have both, which gives you a total of 90 students. So you can see here that a Venn diagram helps us solve a problem here as well. What are the solutions of the absolute value of 2x minus 1 is less than 5? And we're going to write the solutions as either the union or the intersection of two sets. So because it's an absolute value and it's less than, it's going to be an AND problem where we take inside of the absolute value is going to be greater than the opposite of 5 but less than 5. So we're going to solve for x by adding 1. So then we're left with -4. And then we have 2x and 6. And then we're going to divide both sides by 2. And this side by 2 here, we are left with -2, x, and 3. And so what happens is this, when we have an AND problem is an intersection. An intersection is the same as AND, where the graph, we know the graph of AND is where part of the number line is shaded in. That's our AND kind of graph. So this is going to be an intersection problem, where a union is when you have an OR graph where it's split into two directions. So this is an intersection. So when we write our answer, we say all real numbers x such that x is greater than -2. And this is an intersection with all real numbers x such that x is less than 3. Once again, AND problems are intersections. OR problems are the unions. Can you say I can find the unions and intersections of sets? Write a summary and reflection and be prepared for the work time in class.